Okay, we are going to look at rational functions next. And I got to tell you, they look they originally look a whole lot like reciprocal, but they are rational functions. And whenever I abbreviate them, I always abbreviate it as rat fun, which I think is funny because rats are not fun, but see, fun, rat, get it? Anyway, okay, rational functions. Here we go. Rational functions do look a lot like a reciprocal, and I would call them a close cousin, but they get crazy. So here's the definition that we're going to talk about of a rational function. Oh, I think I gave you a sheet for this. Let me find it. Hold, please. Hold, please. Hold, please. Hold, please. Hold, please. Ah, yes, here it is. Ta-da! Oh, no, just kidding. Reverse. Okay, got it. Here we go. Rational functions. So, let's get a definition of this thing. A rational function is a function that can be written as, wait for it, f of x equals p of x divided by q of x, when p of x and q of x are polynomials, and guess what about q? And q of x, what can q of x not learn? What do we learn in reciprocals? It cannot equal 0. So you can't have a 0. We know that. It's undefined. So here are some examples of what this can look like. So it can be something as simple as like 20 over x. All right? This looks very reciprocal-ish, except what is not on top? A reciprocal has a 1 on top because we were taking a function and taking its reciprocal. Here, we're not taking a reciprocal. A rational function is a rational function. It didn't stem from somewhere, if you will. It could also look like this. It could be like 2x plus 30 over x. Or it could be like super crazy. It could be like 4x squared plus 3x over x plus 5. So these are all rational functions. They all have a function in the numerator and a function in the denominator. So they really can come in any form. And again, they are not like stemming from the reciprocal, right? They just kind of are. So q of x, let's take note, q of x cannot be 0. Therefore, we must find the non-permissible value. And do you want to take a shot in the dark at what it's going to do? It's going to cause a vertical asymptote. You are right. Okay, so let's look at what this looks like. Let's just try one, shall we? So let's come on down here. Let's do f of x equals 10 over x. So this is a rational function. There is no parent, if you will. Like, we're not working backwards or doing any of that. What value is going to be my non-permissible value here? What value is not allowed? 0, right? So x cannot be 0. That would give me something undefined. So let's make ourselves a little quick table of values just for funsies. So here's my x, here's my y. I'm going to go -50, and then I'm going to go -10, -5, -1, 0, 1, 5, 10, and 50. And let's see what happens. How does this look different than my, like a reciprocal function? So if I do this, I'm going to substitute these x's in here. So I'm going to have 10 over negative 50, and that's going to give me negative 1/5. And 10 over negative 10 is going to give me negative 1. 10 over negative 5, negative 2. 10 over negative 1, negative 10. 10 over 0, undefined. 10 over 1, 10. 10 over 5, 2. 10 over 10, 1. 10 over 50, 1/5. Okay, let's go graph these and see what happens. So I'm going to go, who gave me a graph that goes to 15? I'm going to call this, okay, we're going to put 50 way over here, and 50 is only going to be up at it's going to be down at negative 1/5. At negative 10, I'm down to negative 1, negative 5, negative 2. Nothing at undefined. I'm going to go over 1 and up 10. And then I'm going to go over to 5 and up to 2. And then I'm going to go over to 10 and up to 1. And I'm going to go over 50. It's way over here. And look what happened here. I forgot that one. Negative 10. So guess what's happening? The same similar situation is happening. It's doing this. And we are getting 2 branches again. So we've seen this before. And where's our horizontal asymptote? Well, it is happening right here at 0 because that's where my non-permissible was. That's great. And can you see that I've also got a horizontal asymptote happening here? This is happening at 0 because as x gets large, what is y approaching? So, like, look right here. If I had 10 over 2,000, what is x approaching? That's about 0. And if I had 10 over 5 million, what is x approaching? 0. So this is going to continue to be my horizontal asymptote if you can keep that thought in mind. So unlike reciprocal functions, we don't have an x-intercept here because we don't have a second function, right? Like all we have is a rational function. Let's discuss, let's kind of summarize here. So our vertical asymptote is at 0. Our horizontal asymptote also at 0. I can really do domain and range now because it's pretty straightforward. So my domain is going to be x is an element of all real numbers, but x cannot be what? X cannot be 0. Range is the same. Range is the element of all real numbers, but y cannot be 0. And then we're going to go back to talking about end behavior. We touched on this earlier in the year. So end behavior, we're going to write like this. As x approaches 0. So as x approaches 0, so that means like as I'm coming in here. Okay, what is y doing? Y becomes very large, right? Doesn't that make sense? Like, look what's happening. As I get closer and closer to 0, as my x's are getting closer to 0, where's my y going? It's shooting straight up. And as my x gets closer to 0 here, my y is still getting large, although it's getting large in the other direction. The value of it is very large, the distance. Okay, let's try another one. Okay, let's look at, I think you've got another one of these on the back side. Okay, it should look something like this. All right, so this time we're going to do one that's a little crazy. So let's say this time we've got y equals, and we're going to get wild here, x plus 2 over x plus 4. Okay, so this no longer looks like anything we've ever done before. So this is a very typical rational function. So let's discuss what's happening here. What is my non-permissible value? It's going to be negative 4, right? Like x cannot be negative 4. So therefore, where's my vertical asymptote? Well, my vertical asymptote is going to be at negative 4 as well. Now, the horizontal asymptote. This is going to be a little different than what we've seen. So remember I told you, asymptotes are eventually going to start moving. They're not always going to be at 0. So we said that horizontal asymptotes exist when x is large. So let's say we substitute in x equals 2,000. So we would have 2,000 plus 2 equals 2,000 plus 4, which is 2,002 over 2,004. Okay. Let's put in a million. We would have 1,000,002 over 1,000,000, I feel like I'm missing zeros, and 4. So what number are we approaching? What is happening here? What if we put in 7 million? We'd have 7,000,002 over 7,000,004. What number is being approached? And actually, even if we come back down, let's look at like smaller numbers. What if we put in 12? We would have 12 plus 2 over 12 plus 4, and that would give us 14 over 16. What number are we getting close to? We are getting close to 1, right? And actually, if you come up in here and look at this, when x is giant, and I'm talking in the trillions, does 2 really matter? 2 is a very insignificant number when we're talking in terms of millions. And the same goes for 4. Almost insignificant when we're talking in trillions. But what we still have is x over x. So if we focus on x over x, what would that simplify to? It would simplify to 1. So our horizontal asymptote is going to occur when x equals 1. Now, all right, so now we have a couple pieces of information that we can come put on our graph. Let me make this a little bit smaller. So we've got a horizontal asymptote that is now at 1, and we've got a vertical asymptote that is at, where, negative 4. So right here. Okay, now we need some table of values here to figure out some more information. Okay, so here's what we're going to do. We're going to make a table of values, and we're going to choose numbers that are around our x, or our vertical asymptote. So I'm going to go negative 10, and then I'm going to go negative 8, and then I'm going to go negative 6, and I'm going to go to negative 5. And then, of course, my asymptote's at negative 4, and just to prove that, we'll put that there. And then the other side of our asymptote's negative 3, then we'll go like negative 1, and then maybe 0 and 1. Okay, now to do this, you're going to take these x values and you're going to plug them in to both x's in your formula. So you're going to say negative 10 plus 2 and negative 10 plus 4. So you're going to do it 2 times. So negative 10 plus 2 is negative 8, and negative 10 plus 4 is negative 6, and that's going to give us negative 1.3, positive 1.3. And then we're going to say negative 8 plus 2 is negative 6, and negative 8 plus 4 is negative 4, and that's going to give us 1 and a half, right? And negative 6 plus 2 is negative 4. Negative 6 plus 4 is negative 2, so that's positive 2. And negative 5 plus 2 is negative 3. And negative 5 plus 4 is negative 1, so that's 3. And negative 4 plus 2 is negative 2. And negative 4 plus 4 is 0, so that is undefined. And negative 3 plus 2 is negative 1. And negative 3 plus 4 is 1, so that's negative 1. And negative 1 plus 2 is 1. And negative 1 plus 4 is 3, so it's a third. And 0 plus 2 is 2, and 0 plus 4 is 4, so this is a half. that a half. Too bad I can't write. And 1 plus 2 is 3, and 1 plus 4 is 5. So, is that right? 1 plus 2 is 3, so 3/5, so like 0.6. Okay. Now, if we go graph all this, we're going to go over to -10 and up to 1 1/3. And, you know, it'd be really nice if somebody had drawn a vertical or horizontal asymptote that was a little bit easier to read. Let's fix this. It should be right on the 1. Look at that straight line. And then somebody should really fix this too, because this is a mess. Okay. This is at where? 4? -4? Let me see if I can draw that a little bit better. Okay. So we're going over to -10 and up to 1 1/3. So that's going to be right above our asymptote. And then we're going over to -8 and up to 1 1/2. So here, and over to -6 and up to 2, and over to -5 and up to 3. Okay, 4 is undefined. That makes sense. -3 is coming down here to -1, and -1's going to a +1/3. And 0 is going to a +1/2, and over to 1 and up to just over that. So here's what's happening. It's doing this, and we're still getting 2 branches like we had before. So we've still got 2 branches. We've still got asymptotes. Our vertical asymptote is our non-permissible value, and our what's that thing called? Horizontal asymptote has moved. Now, we are going to also look for x-intercepts and y-intercepts. So let's talk about x-intercepts. X-intercepts occur when y is 0. So I'm going to replace my y with 0. And I'm going to say x plus 2 divided by x plus 4. And if I want to get x alone, then the first thing I need to do is move this over here. Well, if I multiply 0 times x plus 4, then I get 0. Equals x plus 2, move my 2, -2 equals x. So my x-intercept is at -2, 0. And I would like to know if that is true. And sure enough, if you come look here, yep, what was happening right here? Right here at -2, we were crossing, or we should have been crossing if I was better at drawing. Okay, and then we need our y-intercept. And your y-intercept happens when? Y-intercepts happen when x is 0. So I'm going to replace both my x's with 0. Oops, if I could write correctly. And what am I going to get? I'm going to get y equals 2/4, which is a half. So my y-intercept is going to be at 0, 1/2. And then come look in here. Is that on your graph? Is that about where it was? It is. So there's 4 big pieces of information we got out of this. We found our horizontal asymptote, which was really important. We found our vertical asymptote right here, which was really important. We found our y-intercept, and we found our x-intercept. And those are our heavy hitters. We also graphed all of this. And we saw we still had 2 branches. We still had a vertical and horizontal asymptote. The table of values is useful for now, but we would like to eventually be able to move away from that and only use our the other information we have. Okay, I hope that made sense.